Hi, we're talking about the Colonel Blotto game, and in this lecture I want to do two things. I want to talk about what it means to have a troop advantage, why troop advantage is so useful. And then I want to extend the Blotto game to, instead of thinking of just two people playing Blotto, I want to think about a lot of people playing Blotto. So there's a bunch of people and we're each playing each other sort of one-on-one, and to see what that means in general about competition, if what's really going on is a Blotto game. So let's talk about troop advantage first. Now it seems fairly clear that if I have more troops than you, I'm going to be at a big advantage. So let's suppose there's three fronts, 1, 2, 3, and I have 180 troops, and you've only got 100 troops. So if I go 60, 60, 60, and you've only got 100 troops, there's not much you can do. If you go 50, 50, 0, you lose all three of them. So the only thing you could do to possibly win one would be to say, well, I'm going to put 70 troops on this front, but then you've only got 30 left over. So if you do 70, 30, 0, you're still only going to win one. So what you see is if I've got more troops, I'm at a big advantage. Well, let's think about it a little more deeply, though. So here I've done it with only 3 fronts. What if I increase the number of fronts? Is it having more troops still as useful? Well, here's the result you can prove that's sort of interesting. As the number of fronts increases, so as I add more fronts, if I want to guarantee victory, if I've got the one that's got more troops, I need relatively larger allocation of troops. Another way to put this is this. The advantage of having more troops decreases as we add more fronts. Let's see why that's the case through some examples. So let's suppose that there's 3 fronts. I've got 150 troops. I'm player A, and player B has 96 troops. So player A can just say, I'm just going to go 50, 50, 50 across the 3 fronts, and there's nothing player B can do, because player B at best can do 48, 48, 0, and can't possibly win. But suppose it's the case that we now have 5 fronts. So I've increased the number of fronts from 3 to 5. Well, now player A can do 30, 30, 30, 30, 30 if they do an even allocation across those 3 things. But player B can do 32, 32, 32, 0, 0, and that means player B is going to win all 3 of these fronts and win the game. So what we see, which is interesting, is that when there's only 3 fronts, a 150 to 96 advantage is enough to guarantee victory. But when there's 5 fronts, it's not enough. Hence this claim, as the number of fronts increases, the country needs a larger relative resource advantage to guarantee victory. Now there's another insight that comes from this. So if we've got 3 fronts and I'm going to lose, but with 5 fronts I can win if I'm player B, then it seems like if I'm at a resource disadvantage, what I want to do is I want to create more fronts. And in fact, that's a novel insight that comes from our model, which is really interesting. So we take this very simple Colonel Blotto model, and what we see is if you're the weaker player, so if I have less ability, what do I want to do? I want to add dimensions. I want to add fronts. How would that play out in practice? Well, it would mean I'd add new dimensions to the competition. So if it's a sporting event, I may add trick plays. If I'm competing in the business world, I may add a new dimension to the product. So if my product's lower quality than your product, I may try and add color or packaging or some other dimension that I can add to it in order to make it so when people do the comparison, mine looks better. If I'm a terrorist organization, what do I want to do? I want to attack in places that you'd never expect it. So if you're the weaker player, you want to add new dimensions. And in fact, people who study war and people who study insurgents, this is one of the key insights that they have. They say you always find that weaker opponents are adding new dimensions, are sort of attacking in places that weren't expected beforehand. And we see why that's true from Blotto. Because if you've got very few fronts, the stronger player has a big advantage. If you've got lots of fronts, the stronger player has less of an advantage. Okay, let's move on to the next thing, which is multiple player Blotto. So here what I've got is I've got a whole bunch of people. They're all allocating their troops, whatever these troops are, their resources, across these fronts. And they're going to play each other pairwise. So let's suppose you've got the following 3 players, player 1, player 2, player 3. And what they've got is we've got 5 fronts, and we've got 20 troops. So they've allocated their 20 troops across these 5 fronts, and let's see what happens. So when player 1 plays player 2 wins on these 3 fronts, so player 2 is the winner. So 2 beats 1. When player 2 plays player 3 wins on these fronts, so 3 beats 2. So now we have the standard thing. 2 beats 1, 3 beats 2. What do we think happens when 3 plays 1? Now we'd expect 3 should win, but in fact the opposite holds. Player 1 wins on these three fronts, so player 1 wins. So we basically have 1 beats 3, who beats 2, who beats 1. So we have one of these cycles. So what we get is that in kernel Blotto, if we're playing multiplayer Blotto, we should expect to see quite a few cycles. And that's something that, again, you might not expect if you had, remember the skill luck model we did before, you might not expect to see cycles like this. But Blotto, cycles would be something you'd expect to see almost all the time. In fact, then what you can think of is Blotto, if played correctly with a whole bunch of people, really just becomes a really sophisticated version of rock, paper, scissors. You want to choose something that's like rock, somebody else is going to choose paper, somebody else is going to choose scissors, and it's just going to be random who wins. Okay, so we've now done 2 extensions to Blotto. One, changing the amounts of troops, and what we see is the weaker player wants to add more fronts, and the advantage of being stronger really depends on there being, not as many fronts relative to troops. And then we've seen if we go to a multiplayer Blotto game that we're likely to get cycles where 1 player beats 2, 2 beats 3, and then 3 can beat 1, or something like that. So we get these interesting cycles. We don't get sort of a consistent winner. So what Blotto does, if we have a situation, a competitive situation that looks like Blotto, we have some understanding of what the structure of winners should look like. And that's different than some of what we've seen in our other models. And that's where we'll go next. All right, thank you.